For number 1, to evaluate this sum, you could use the summation techniques talked about in 7.1. I'm going to go through it with the techniques from 7.2, the finding the sum of the first n terms of an arithmetic sequence. And on page 673 are the two formulas you can use. I'm going to use this one, where if you know the first term and the last term, and n is the total number of terms there are, then you can go ahead and find the summation. Now this summation only has 4 total terms in it, so you could actually work it out just by finding those 4 terms and adding them together, which here they are. If you plug in I equals 3, you get 4 times 3 is 12, minus 3 is 9. Plug in I equals 4, and you get 13, I equals 5, and I equals 6. So here are your 4 terms. You add them all together, you would get 60. But it's good to know how to use the formulas, because sometimes these can be a lot longer than just 4 terms. If this could go all the way up to a much larger number than 6, maybe it went up to 100 or 1,000, and you would not want to try to write out all 1,000 terms and add them together. That would take you a very long time. So you'd want to use the formula. Now D here is the difference between each term, and just by calculating the first few terms, you can see that each term gets 4 larger. And we don't need D in this formula, but if you're using the formula where you don't know the last term, then you do need to use D. And N is the total number of terms there are, and going from 3 to 6 is a total of 4 terms. And so we plug these values in here to the formula, and then it's just reducing, and you'll get that the sum is 60. Number 2, we're finding the sum of the first 5 terms of a geometric sequence. And this is in chapter 7.3 in the text, and this formula is on page 681. Formula you will need for summing the first n terms. You need to know the first term, and you need to know what each term is being multiplied by to get to the next term. And here each term is being multiplied by 2 to produce the next term. So R is 2. And just plug these values into the formula. And we'll come over here with them plugged in. And 2 to the 5th is 32, and 1 minus 2 is negative 1. That's what we get down here. And then actually do this subtraction. Negative 31. 4/3 times negative 31 gives you that value. And then dividing by a negative 1 is basically just going to flip the sign. So this fraction, negative 124 over 3, divided by negative 1 will just become positive 124 over 3. And that's the sum of the first 5 terms. Number 3, we're going to be expanding this expression. And this is talked about in chapter 7.4. On page 694, it shows you the binomial theorem. And you need to identify what the 2 terms are inside the parentheses in order to use the binomial theorem. So the first term, just using the same letters they use on 694, they use an x and a y. So the first term they call x, and for us, our x is 2x. And the second term they call y, and for this example, our y is the number 3. And so now we just need to plug these 2 values in to the formula. And one thing you'll notice about the formula, and I'll keep re-emphasizing this, the exponents always add up to what the exponent is in your original expression here. So you start off with just your x term here raised to that exponent. And then you do 4 combination 1, that's going to be your coefficient. And then your x term's now raised to 1 less than it was originally. So now it's to the 3rd. And your y term is raised to the 1st power, because again, these exponents have to add up to 4. Then your next coefficient is 4 combination 2, which gives you 6. And your x term is raised to 1 less again, so instead of the 3rd power, it's down to the 2nd power. And again, the exponents have to add up to 4, so your y term here is raised to the 2nd power as well, so those equal 4. Then your coefficient, is 4 choose 3, and that gives you the answer 4. And your x term, again, goes down by 1 exponent. So instead of 2, now it's to the first power, which means our y term has to be to the third power in order for our exponents to equal 4. And then finally, we have just our y term to the fourth power. And so from here, it's just simplifying. Do 2 to the fourth power and x to the fourth power, you get 16x to the fourth. 2 to the third is 8, and then x to the third. 2 squared is 4, x squared. 3 squared gives you 9. 3 to the third is 27. 3 to the fourth is 81. And from here, you just need to multiply. So that term doesn't change. Here, 4 times 8 times 3 is 96, and so on. Multiply the values out, and you'll get your final expansion.